By 2050, billions of people could face severe water shortages. And honestly, it's not hard to see why. AI data centers consume massive amounts of water just to cool their servers, rivers are shrinking, and underground aquifers are being drained faster than nature can refill them. Some experts even worry that future conflicts may be fought over fresh water instead of oil. But a recent discovery beneath the Atlantic Ocean could change the conversation completely. Scientists have confirmed the existence of a gigantic hidden reservoir of fresh water buried deep beneath the ocean floor off the eastern coast of the United States. Normally, researchers drill down there looking for oil or natural gas, but this time they may have found something even more valuable: water. During a major expedition near the East Coast, scientists drilled hundreds of feet beneath the seafloor and discovered huge layers of sediment filled with low salinity water. Early evidence suggests this underground aquifer could stretch for more than 300 miles, from New Jersey to Maine, and researchers still have no idea how massive it really is. Some estimates suggest reservoirs like this could potentially support millions of people for decades, especially if similar systems exist in other parts of the world. And that matters because less than 1% of Earth's water is easily accessible freshwater. Everything else is trapped in oceans, glaciers, ice caps, or deep underground. So every new freshwater source suddenly becomes a very big deal. What scientists found beneath the Atlantic is basically a giant underground sponge soaked with freshened water. Water that contains far less salt than normal seawater. In some places, the salinity was surprisingly close to freshwater found on land. Now comes the biggest mystery. Where did this water even come from? One theory is surprisingly simple. Scientists think the freshwater may have been trapped beneath the seafloor like cheese sealed inside a giant calzone. During the Ice Age, sea levels were much lower, and parts of today's ocean floor were actually dry land. Rainwater soaked underground like normal groundwater. But when the glaciers melted and sea levels rose, thick layers of sediment folded over the water like a crust, sealing it beneath the seabed for thousands of years. The second theory is even stranger. The water may have formed beneath giant glaciers tens of thousands of years ago. Right now, scientists are trying to figure out how old the water really is and whether the reservoir is still being replenished today. Because if freshwater is still slowly flowing into the system naturally, this discovery could become one of the most important hidden resources on Earth.
For millions of years, something has been lurking in the depths of the ocean. You can't see it, touch it, or map with sonar, yet it keeps entire species trapped where they are. Recently, scientists uncovered its victims, strange jellyfish cousins that look almost identical, except for one odd detail. One travels the world's oceans, the other is stuck in the Arctic, unable to escape. What blocks its way? It's not ice, not land, not even depth, something far stranger. Let's take a look at this mystery. The jellyfish in question belong to a subspecies with a pretty complicated and hard to pronounce name, so I won't. See? Anyway, they live very deep in the ocean, about 3,300 to 6,600 feet down. That's so deep that sunlight doesn't even bother showing up there. The strange thing is that some of these jellyfish have a little bump or knob on top of their umbrella-shaped body, and others don't. And this tiny difference decides their entire life story. Jellyfish with a knob are world travelers found across all oceans. Jellyfish without a knob are stuck in the Arctic, like they're grounded for life. To figure out what was going on, scientist Javier Montenegro and his team looked back at more than 120 years of jellyfish photos and sightings. Then they added in modern DNA testing. The results were curious. Genetically, the knobless and knob jellyfish in the Arctic were identical to knob species in the Western Atlantic. In any case, this bizarre similarity aside, only the knobless jellyfish are trapped in the north. So, what's keeping them from leaving? It's not a giant underwater wall or a rocky barrier. Instead, scientists think the wall is biological or linked to geography. Just like something called the Wallace Line, nature's invisible border. So imagine sailing on a boat in Indonesia, crossing from the island of Bali to the island of Lombok, It's only about 22 miles, not even enough for a long nap on deck. Once you're there, the beaches look the same, the weather feels the same, and the palm trees all sway the same way. But when you look at the animals, it feels like stepping into a different universe. Birds, mammals, even reptiles suddenly don't match what you just saw a short distance away. That invisible line dividing the two worlds is the very Wallace Line. The story began in 1859. Alfred Russel Wallace, a British naturalist, traveled through the East Indies. While hopping between islands, he noticed something that didn't make sense. On the western islands, like Borneo and Bali, the animals all look like they belong to Asia. Monkeys, tigers, woodpeckers, the usual. But east, the animals seem to have come straight out of Australia. Marsupials, cockatoos, even kangaroo cousins. The two sides weren't blending at all. Wallace realized that a narrow stretch of water could act like a massive biological border. How could two islands, close enough to see across the water, host such different wildlife? The line is not just some quirk of nature, but the result of powerful geological forces. Between the islands, there are underwater trenches that have never dried up, even when ancient sea levels rose and fell. To the west, you can find the Sunda Shelf. That's an enormous sunken platform that once connected Asia to nearby islands. That's why Borneo, Sumatra, and Java are packed with Asian-style wildlife. To the east is the Sahel Shelf. It once linked Australia and New Guinea, helping Australian species spread. The Wallace Line slices right between these shelves. This part of the world, the Indo-Australian archipelago, is where four massive tectonic plates slam into each other. As the seas rose, animals became trapped on islands. When seas fell, some species made it across, but not so many. That's why two islands, separated by just a short boat ride, ended up with completely different ecosystems. The Wallace Line isn't some recent discovery. This invisible border has been messing with animals for millions of years. Now, back in the Pleistocene, when giant mammoths roamed our planet and the oceans were up to 400 feet lower, many of the islands in Indonesia were actually connected. Tigers and elephants could stroll from place to place without ever touching water. But even when sea levels dropped that much, Asia and Australia never linked up. There was always a stretch of really deep water between them, and that watery gap acted like an uncrossable wall. For more than 50 million years, it's been stopping animals from mixing, keeping Asia's lineup on one side and Australia's weird crew on the other. That middle zone of islands, the ones stranded between the two continents, is called Wallacea. Only animals that could swim, fly, or somehow make it across the open ocean managed to live there. Everyone else was stuck at home, no exceptions. As you see, there can be a logical scientific explanation for almost any phenomenon on Earth. Maybe we could find one of those poor trapped jellyfish. Apparently, the problem lies in the North Atlantic Drift. It's a warm current that flows up from the Gulf Stream. Scientists don't know exactly why, but something about this area blocks the knobless jellyfish. One theory claims that predators beyond the drift are too dangerous for these creatures. Another idea is that the knob itself somehow gives jellyfish an edge in survival, but no one really knows. For now, it's like an invisible border. Knob jellyfish pass, knobless jellyfish stay put. On the Pacific side of the Arctic, there's no need for a mysterious barrier. The Bering Strait already does the job. On average, it's only 165 feet deep, which is way too shallow for deep-sea creatures to get through. So these jellyfish, knob or no knob, can't escape south. And since we're back at the topic of animal life, let's speak a bit more about the weird fauna quirks of the Wallace Line, because animals are the easiest way to see this barrier in action. Birds, for example, often refuse to cross even the tiniest gaps of open water, so their species stop right at the line. Mammals are even stricter. Bats can cross because they fly, but larger land animals never made the jump. On the Australian side, it's all about marsupials like kangaroos and possums. You'll also find native rodents that settled there more recently. On the Asian side, you get a different cast: apes, elephants, tigers, cats, monkeys, rhinos. Sure, there are some oddball exceptions. Sulawesi, right in the middle of the divide, has macaques, pigs, and big-eyed little tarsiers. But overall, the split is obvious. Step off the boat, and the animal world changes completely. But then, what about plants? Well, they don't always follow the rules as neatly. Seeds can hitch rides on birds, float on water, or get blown by the wind. But even here, the Wallace Line shows up. Take eucalyptus trees, for example. They're as Australian as kangaroos. Almost no species make it across to Asia. There's just one exception, which somehow popped up on Sulawesi and the Philippines. That's the magic of the Wallace Line. Two islands can look the same climate, same forests, sometimes even close enough that you can see across the strait. But their animals are like night and day. And it's all because of an invisible border in the sea that's been in place for millions of years. Such discoveries might sound small, but they're important. They show us that there are still hidden boundaries in the ocean that humans don't understand. These invisible fences could explain how marine animals spread, evolve, and survive. As scientists put it, finding two different body shapes inside a single genetic family shows how little we know about jellyfish and other gelatinous creatures. As for the Wallace Line, even today, it stands as one of the most fascinating mysteries in biogeography. It reminds us that life doesn't always spread evenly. Sometimes, a short stretch of water can act like an uncrossable wall. There's a lot more mystery in the deep sea than we thought. You're lazing around on the deck of the ship when you see something whitish-gray covering the horizon. Like in a horror movie or your worst nightmare, this weird fog is nearing the vessel. It's infinite. You can't see where it starts or where it ends. Soon it makes the ship look like a grain of sand in a vast desert. That's when the realization hits. It's an iceberg, and your ship is likely going to repeat the Titanic's fate. Now, all this is a very likely scenario, since the world's biggest iceberg, A23A, is on the move again after months of spinning in a huge water vortex. And it's actually the second time in just a couple of years that this massive chunk of ice has broken free. The first time was in 2023, when the berg went wandering around after being stuck on the seafloor for a staggering 37 years. The thing is huge, about 3 times the size of New York City. It also weighs nearly 1 trillion tons. The giant chunk of ice first broke off from Antarctica's Filchner ice shelf back in 1986, but instead of floating away, it got grounded on the seafloor just a few miles from where it started. Because of that, it melted much more slowly than most icebergs. In December 2023, A23A finally broke free and started to drift away from Antarctica. But it didn't get far before getting stuck again, this time near the South Orkney Islands. It got trapped in something called a Taylor column. That's a huge spinning water current that forms when ocean currents swirl around an underwater mountain. At one point, A23A was rotating around 15 degrees counterclockwise every day. Luckily, as of December 2024, the iceberg escaped the Taylor column and is now slowly moving again. Researchers are super curious to see if it'll follow the same path as other giant icebergs that have broken off from Antarctica, or if it'll find its own unique way. Such enormous icebergs, such as A23A, release nutrients into the water as they melt, and it can actually create hot spots of life in parts of the ocean that are usually pretty empty. But there's still a lot we don't understand about how the size, shape, or origin of the iceberg might affect that process. So, to figure it out, scientists have been collecting water samples from the areas A23A is expected to pass through, and they'll keep collecting samples as it drifts along. Hopefully, it'll give us a better idea of how massive icebergs like this one influence the ocean around them. By the way, the glacier our monster of an iceberg was once part of could be very, very old, literally ancient. In Antarctica, the oldest glacier ice might be close to 1 million years old. Over in Greenland, the oldest glacier ice is more than 100,000 years old. And in Alaska, the oldest glacier ice ever recovered, found in a basin between Mount Bona and Mount Churchill, is only about 30,000 years old, a mere child. At the same time, in a typical Alaskan Valley glacier, it only takes about 100 years for newly formed ice to travel through the entire length of the glacier. For something like Bering Glacier, which is Alaska's largest and stretches over 140 miles, the ice can move through the whole thing in less than 400 years, and that's a lot of movement for such a massive glacier. Now let's move on to Iceberg Alley, a stretch of the Atlantic Ocean that runs from the Arctic to Newfoundland. If you want to see as many icebergs as you can, that's the place to be. Tons of icebergs float through this place every year. Most of them come from Greenland. In spring and summer, big chunks of glaciers break off and get carried by north-south currents through Baffin Bay into the Labrador Sea, where they eventually melt. Some icebergs also come from Canada's shoreline, traveling through the Davis Strait and into the Labrador Sea before drifting along Newfoundland's eastern and western coasts. These massive ice chunks are really old too, about 10,000 years. Every year, about 400 to 800 medium and large icebergs pass through Iceberg Alley. How fast they drift depends on their size, shape, currents, waves, and wind, but the average speed is less than a half mile per hour. Now, there are 6 types of icebergs that make their way through Iceberg Alley. Tabular icebergs are flat slabs of ice, much wider than they are tall. Blocky icebergs have steep sides and sharp angles, like cut-off pyramids. Wedged icebergs have one steep side and one sloping side. Dome icebergs have a rounded top. Pinnacle icebergs have one or more steep peaks sticking up. And dry dock icebergs are U-shaped with a hollowed-out section. They all look incredible. Comment below which is your favorite type. Anyway, as these icebergs drift south, the warmer water speeds up their melting, making them pretty unpredictable and sometimes dangerous. Nowadays, satellites help track medium and large icebergs to prevent accidents, but smaller icebergs can still be risky for small boats. One iceberg made headlines in 2018 when it got unusually close to the Newfoundland village of Fairyland. Pictures of the giant iceberg towering over the village's houses went viral. It got stuck in a 330-foot deep water, which turned out to be too shallow for its massive size. And now I'll take you on an unusual journey to the past to witness the birth of something beautiful and equally disastrous. Its very existence led to one of the greatest tragedies in history. Watch, an enormous chunk of ice is breaking off a glacier in southwest Greenland. It's made of snow that fell over 100,000 years ago, when mammoths were still wandering around the planet. The enormous iceberg starts its long journey. It stretches more than 1,700 feet in length and weighs 75 million tons. Despite its size, it's pretty peaceful and stays far away from ships and the busy transport routes near where it was born. But then, it starts floating south, much farther than most icebergs ever get. Usually, icebergs like this melt way before they reach such warm waters. Out of the 15,000 to 30,000 icebergs that drift away from Greenland's glaciers every year, only about 1% make it all the way to the Atlantic. So the fact that this iceberg keeps going and reaches over 5,000 miles south of the Arctic Circle by April makes it truly unique. Even after months of melting, this block of ice is still incredibly massive. It weighs around 1.5 million tons, which is almost twice as much as the Golden Gate Bridge. Above the water, its visible parts tower more than 100 feet high. But like most icebergs, the majority of it, about 90%, is hidden below the surface. The iceberg's story takes a tragic turn on April 14, 1912, when, guess what? Yep, it comes across the ocean liner Titanic. The ship is about 370 miles from Newfoundland in the North Atlantic Ocean when the iceberg seems to appear out of nowhere. The crew doesn't spot it until just minutes before the crash.
Welcome to another Mystery Minute. Can you solve this magic? Like and subscribe for more.